Hi guys, Mr. Broly here. So today we're going to talk about 4 tips to make it easier for you to integrate. So the first tip is, if the difference of the exponents of different terms are exactly 1, then we can use the U substitution to integrate, and make sure to use a high-powered term as U. To make it clearer, make it better, we have this example. So if we integrate x squared minus 1 raised to 5 x dx, we can notice that the difference in powers between x squared and x is 1. Therefore, we can use the U substitution. So make sure we use the high-powered term as U. In this case, x squared minus 1 has the highest power. Therefore, we use it as U. Therefore, U equals x squared minus 1. Therefore, du equals to 2x dx. And therefore, x dx equals to 1/2 du. And therefore, we substitute everything into the original. Therefore, we get u raised to 5 du and a half equals to u raised to 6 divided by 12 plus c equals to x squared minus 1 raised to 6 divided by 12 plus c. Alright, so this is my first tip. This way is going to make you integrate better and faster. And my second tip is, you should break fractions into products and then change the radicals to the exponent of a function. Let's look at an example. So in this case, we have radical x minus 1 raised to 5 over radical x dx. Alright, this function looks difficult to integrate in the beginning, but if you change the radicals into fractions, this actually equals to x raised to 1/2 minus 1 raised to 5 over x 1/2 dx. And then we change the fractions into products. Therefore, we get you see, actually now we can say the difference between this and this are 1 in their power, therefore we can use the U substitution. Now this is easy. I'm not going to solve it for you in here, alright? Alright, and my next tip is, if there's a linear polynomial as u in the function e raised to u or x in the trig functions such as sin x, then we can integrate it as if the u or x are singular, and then multiply the reciprocal of the coefficient of the linear polynomial to the entire answer. Let's look at an example. To integrate e raised to 2x dx. Normally you would like to use U substitution, but if you follow what I did, just view the whole thing as a singular function, then we can just integrate. Then we get this actually equals to 2x. We viewed the 2x as singular, and we just applied the formula right here. And we should follow our next step. We find the coefficient of the linear term is 2x, and the coefficient is actually 2, and we multiply the reciprocal of 2 in front of it. That's how you do it. This can also be done in the trig functions, and it can make your life a lot easier. Alright, and my last tip is, if parts of the integral are polynomial, then we can use the tabular method because we can integrate the polynomial to 0. So let's look at an example. If we want to integrate x squared times e raised to x dx, we see that here's the polynomial x squared, and since it's a polynomial, we can integrate the whole thing to 0, therefore we can actually integrate it. So let's set everything up. Here we have plus minus x squared ex. In this case, we find the derivative of the whole thing. 2x, the derivative of 2x is 2, and then we differentiate the whole thing again, we get 0. And the integral of ex is always ex, so we get ex for every single term. And then we cross multiply, and our answer is x squared ex minus 2x ex plus 2ex plus c. And in this case, we just solve the function because the parts of the integral is a polynomial. Here's my lesson for today. I hope you learned something new today. If you are not subscribed, please subscribe, and please leave a like and comment down below. I will see you next time. This is Mr. Pro Lee. Thanks.